So we're gonna learn how do you find that function? How do you take an equation and find the derivative function that you can use to find the slope at any point? How do you do that? Well, we're gonna learn 3 rules. I think I went over this one with you guys yesterday. Okay, so with this one, when you have y equals a number, like y equals 2, for instance, right? We said that looks like a what when you graph it? A horizontal line, right? And derivative tells you the instantaneous rate of change at any point. Or, in layman's terms, it tells you the slope at any point, right? Well, what is the slope at every point on this line? 0. So the derivative is just 0. So what we learned yesterday was that the derivative of a constant function is just 0 because the slope is always 0. Okay? So that's my function. You could write it like this if you wanted to, y prime of 1, but this is saying the derivative is 0, right? This is saying the instantaneous rate of change at 1 is 0. It doesn't matter because it's 0 everywhere. Okay? All right. So that's what we learned yesterday. Now, we didn't get to this, I don't think, right? So let's talk about this one then. All right. So let's say it's like y equals 2x. This is called a linear function, right? Remember mx plus b? I'm not putting the b on there. I'm just going to put mx for now. Y equals 2x. So if I wanted to graph that, what is my y-intercept?
0.
And my slope? So over 1 up 2, right? I'm just going to graph this really quick. Well, what do you know about the slope of a linear function no matter what 2 points you pick? It's always the same. Never changes. The slope of a linear function is always the same, right? Now, what is the slope of this function? 2. So, no matter where we pick on this curve, the slope is 2, which means the formula for the derivative is? It's just 2. It's just that number right there. So in other words, or you could put it up here like this in general form. Yeah. It doesn't matter what point you pick. So even if you were to do y prime of 3, it's just going to be whatever the m value was anyway. It doesn't matter what you plug in here. The slope is always the same. Okay? Yeah.
So the slope is always the derivative of the
I like to talk like that in the beginning of the year, but here's the difference. Slope is what we call the slantedness of a line, a straight line. Okay? Now, when you start talking about curved lines, you can connect 2 dots with a straight line and call that the slope. But what we call that for the curve is not the curve slope, but we call it the average rate of change, right? The derivative is a formula that helps you find the instantaneous rate of change at a single point. Or in other words, the slope of the tangent line at that point. So that was a huge answer to what probably seemed like a very simple question, but does it make sense? Okay, so technically slope is just really for straight lines, but it's kind of how we're thinking about all this anyway with straight lines. So that's why I keep saying slope. Are we good? Yeah. Oh, good, thank you. Any other questions? All right. So let me throw some questions at you guys then here. Let's say that f of x is equal to 3, and let's say that g of x is equal to 9x. Okay. What am I asking for here? Good, and we can say that with one word, the derivative. So, what's the derivative? 0. Why? Because this is a constant function. This one over here, g prime of x. I'm looking for the derivative again, or the slope at any point along the curve, right? And it's just 9 because the slope of this is constantly 9, no matter where you go. Okay? I see some twisted eyebrows. So just in case, I want to give you guys a little more practice. How about m of t equals 6t? And how about y equals 8? I would like you to find m prime of t, and then I would like you to find y prime. See if you can find both of those. I'll give you a second. Where are you? Hi, Jennifer. So what did you get for m prime of t?
M derivative t equals 6.
Good. That's correct. Let's do Ashley. Hi, Ashley. What did you get for this one?
0.
Good. So it's slope, right? We're just talking about slope. If I were to step into an Algebra 1 class and erase this crazy looking symbol here and just ask the kids what the slope is, they would get the same answer as you. Okay. That's all it is. But now we're gonna do some calculus, stuff that the Algebra 1 kids don't do. You ready? So yesterday, for the homework for the night before that, I told you this was our function. Do you guys remember what I told you the derivative was? There's a way you're gonna know how to get that now. How the heck did I know the derivative was 2x? So I'm going to show you. It's called the power rule. So this is what we call a power function. A power function is when you have x to a number of some kind, like for instance, y equals x squared, right? Okay. Well, here's the power rule. It's weird. You're not going to know why this works. I will tell you in Unit 4, like December or January. But for today, I'm just showing you this is how you get it. It's voodoo. It's going to be like magic. It's like, really? That just works? And I'm going to say, yes, it just works. Why am I teaching that way? Usually as a math teacher, I like to show you why something's true and then give it to you. But in AP Calculus, since we're really trying to get you guys ready for this test, I like to give you the facts up front, and then we'll talk about the why as we go. Okay, so for now, here's the rule. Here's how you can find y prime. Ready? You take this exponent in, and you put it in the front, multiplying it by the whatever's here. So multiply the exponent to the front. Then you take 1 away from this exponent. So n minus 1. So put this number in the front, and then take 1 off the exponent. Why does it work? Magic. We'll learn later. All right, so let's take a look over here then. Y prime. What am I going to move to the front? 2 times x, and then I'm going to take 1 away from this power. What is that? So it's y prime is 2x then. Cool? This works. We'll figure out why that is later. But for now, that's called the power rule. It only applies to power functions. There's all kinds of functions. There's log functions, trig functions, radical functions. Well, radicals actually apply here. You'll see that later today. But they have different rules. Power rule is its own thing. It applies to power functions. And it's probably one of the most common ones. So and it's easy, so it's a good place to start with. All right. So let's do some problems. Let's start with part B. 3t, yes. You're right. And we're going to show you that down here, so it actually is a power rule. You're correct. All right, let's come back up here to part B, though. For part B, I want to find the derivative of h with respect to t. So if I want to find the derivative of h with respect to t, what am I going to multiply to the front? 4. So it's 4 times 3t, but my power is going to change. What's my power going to become? There you go. So final answer, 12t cubed. Cool? So this formula here, 12t cubed, will tell you the slope of this function at any point. So for instance, if I asked you, what's the instantaneous rate of change of h at t equals 2? You would take your derivative and you plug in 2. And that would tell you the slope of the tangent line when t equals 2. So just for the heck of it, let's do that real quick. So I guess I should have just had 12 here. Let me simplify that. So 2 to the third power is 8, and 12 times 8 is, that's a really steep line. So for this function, by the time you get to t equals, I think this function looks something like this. So by the time you get to t equals, what are we plugging in? 2, you're here. That line is so straight and vertical. The rise, it's like over 1 up 96. It's a really steep function. It has a very fast rate of change at that point. All right, so let me throw one at you guys. How about m of y equals 6y to the third power? Go ahead and find the derivative of m with respect to y. It's different notation, but you know that means the same thing, right? Go ahead and find the derivative of m.
I didn't finish it.
Okay. Were you stuck?
Yeah, I was stuck.
Okay, so what I'll do is I'll walk you through it. So we're going to multiply 6y by something. What are we going to multiply 6y by? Yes, so we're going to put that in the front, right? And then we're going to do something to this power. What are we going to do to it?
Would you subtract 6y?
We're going to subtract it by 1.
Okay.
So what's 3 take away 1?
2.
Yeah. So now it's y squared.
Okay.
And then we can simplify these coefficients. 3 times 6 is 18. So it's 18y squared. Okay. All right. So that's the derivative of m with respect to y. Let's move on. Let's talk fractions for a second. G of m. This is part C. I don't know why I left off part A. Okay. The same rule applies. I'm just doing this because fractions aren't fun. Yeah.
So, if you change the notation of it, you don't have to rearrange your answer. Like that last one is like a function like f of x or something. Then you switched it to the fraction notation, but the answer stayed the same. Is that always going to be the case?
I was just showing you can use either form of notation for a derivative. So yeah, it doesn't matter which. Like if you would have put m prime of y, was that it? That would have been fine. Yeah, and I just want you guys to get used to the different types of notation. All right, so let's go ahead and do this one. So, Zechariah, what am I going to multiply to the front?
We're going to multiply to 3.
Good. And then I'm going to ask Chris, what's the exponent going to be?
2.
Good. Now, the only reason I'm doing this is for this one right here, right? You could either multiply straight across and get 6 over 3 and reduce it, which would be what? 2. Or you can just cross reduce and get 2. But the point is it's 2 instead. Okay? Does anybody feel like they need to practice that before I move on to the next topic? Let's do one, just in case. How about, let's do y of x equals 4 over 3 x to the 6th power. Find for me y prime of x. One down here. So what?
5.
Yes. So multiplying 6 times 4/3 would give you 24 over 3, which is 8, and then taking 1 off of there is 5. So there's your fraction. Now we're going to take it up a notch, but before we do, I want to share with you guys a quick way to do some subtraction. So suppose we had this 3/5 minus, well, I don't want to use 3/5. Let's say we had 4/9 minus 1. If I want to subtract that, what do I need to do? Common denominator. So what is the common denominator? So this will be, so we're going to have 4 take away 9, which is, okay. Now, that's a lot. You guys know that we're doing this type of math where we have to subtract 1 from stuff, right? Well, now we're going to have to be subtracting 1 from a fraction. So I want you guys to have a kind of a shortcut so you don't have to do that every time. Unless this is already easy for you, then don't worry about it. But basically, I can go straight from here to here because What's 4 take away 9? -5. You just keep the denominator the same. So like, what if I said, what's 3/7 minus 1? Well, what's 3 take away 7? -4. Keep the denominator. You good? Yeah?
Just make sure the only word that's subtracting is 1.
Yes. Yes, this is only for subtract, and that's what we're doing when we do the power rule, so that's why we're learning that. So let's do one more here. See, just in case you guys need it. 8/5 minus 1. I'm going to call on you. So check your answer with a neighbor if you need to. Hey, oh, you have it? I'm going to use my cards. Thank you, though. Who's Brandon? I'm sorry. Hi, Brandon.
-3/8.
There you go. -3/8. You guys good? Okay, so that's the main aha moment there. I want you guys to be aware of. All right. So now that we know that, let's go ahead and move on to part C. I'm sorry, part D. Part D says Q of x is equal to 2x to the 2/5. Okay. So what am I going to multiply to the front if I want to find the derivative? What is it? 2/5 times 2, right? And what's this going to be if I take 1 away from it? See, that little shortcut's nice. We don't have to go do math on the side now. We just, oh, it's -3/5. Okay? We can simplify this. That'll be 4/5 x to the -3/5. Oop. Good? That's all you have to know. But I'm going to ask you to write 2 more things for this problem just to kind of get you ready for what's coming up in a little bit. Okay? That we don't, in math, we typically don't like leaving our answers with negative exponents. Do you guys remember what negative exponents do? I'll take that answer a little bit later. What's it? But what do you think it does? There you go. It makes a reciprocal, right? So since this x has a negative exponent, I want you guys to be aware of, because it's coming up later, that we can also write it like this. You can put this x to the 3/5 in the denominator and then make it positive. Negative exponent. If you have a negative exponent, you can throw it to the bottom and then you can make it positive. That's a common way to write your answer. I will accept this for now. That's totally fine, but I'm just getting you ready for stuff coming up later. That's something you want to know. And then Brody mentioned something as well. And what you were thinking of is this. When you have a fraction exponent, you guys remember what that does? Those make roots. Okay? So another way you can write your answer is you could say q prime of x is equal to 4/5, and you could rewrite this as a radical x, where the 5 tells you what kind of a root it is. It's a 5th root, and the top number tells you the power inside. So you could rewrite this as the 5th root of x cubed as well. So those are different ways to write your answer. But for now, unless you want to practice these other 2, this is fine for now. Okay? All right. Can I erase? Okay, so let's do one like this. Let's say I have f of x is equal. It does that sometimes. Just gotta wiggle these. Then I gotta push a button. No. Okay. So let's say I have f of x equals 2/3x to the 1/5 power. Okay? So So let's see if you guys can do that. Go for it. Find for me f prime of x. That's right. So if we multiply 1/5 to the front, you're going to end up with 2 over 15, right? And if you take 1 away from that, you're going to get negative 4/5. And I think Jacob just went ahead and put it in the bottom as a positive 4/5. So you could have written your answer like that. You could have written your answer like this. Or you could have written your answer like that. Either way is good. Yeah, so if you multiply this times the front, you're going to get 2 times 1 is 2, and 5 times 3 is 15. And then if you subtract these, you get negative 4/5. All right, so there's that. Move on to part E. Nakia? What's the answer? What's y prime going to be? Yes. Don't forget that. I snuck it in there, right? By the way, this actually is the power rule. Want me to prove it to you? Don't do this. It's like a terrible waste of your time, but it's interesting. So I'll show you one time. Don't you guys agree that y equals 6 is the same thing as y equals 6 times t to the 0? What's t to the 0? T to the 0 is 1, and 1 times 6 is 6. So this is the same thing. It's just 6, right? But let's do the power rule. Multiply that to the front. Take 1 away from there. Well, 0 times anything is 0. Okay, so the power rule still works on those. That would be weird to do that, but you can do it. All right, let's do the next one, part F. So we have y equals 2 over x to the 3rd power. Okay, so this is a special circumstance. When your x is in the denominator, that's not a power function. That's a rational function. So you can't actually apply the power rule right now. Rational functions, whole different rule for finding the derivative. But I can turn that into a power function. When x is in the denominator, rewrite as a power function. So how can I do that? Well, a power function is whenever you have your number, which in this case is 2, right? But I don't want it 2 over x cubed. I want it 2 times x. But if I put the x in the top, what's that going to do? It's the same thing. It's just rewritten as a power function now. Think it's good? Now we can do our power rule. So now we do the derivative. So I'm going to multiply what to the front? And then I'm going to take 1, now be careful here. I'm going to take 1 away from negative 3. What's that going to be? And negative 3 times 2. Now, I can leave my answer like that, and I will, but you guys know that we can rewrite that, right? That x to the 4th can go to the bottom to become positive. All right, so that's another thing I want you guys to be watching out for. Would anybody like to practice that one before I do this one? Or would you rather I do both of them and then let you do both? Any opinions there? Anybody want immediate practice right now of that? Okay, we'll move on to the next one, then we'll do them both at the same time. We'll see how you do. I don't want to overwhelm you. All right, here's another one. Y equals the cube root of x to the 4th power. Well, that's not a power function. That's a radical function. But, once again, I can rewrite my radical function as a power function. And we kind of learned that a few steps ago also. I can change that into y to the power of what?
X to the negative 4 over 3.
Non-negative. the negative thing comes from when it's in the denominator, right? But in this case, it's not. But you are right, it's 4 over 3. So this number is going to be our bottom number, and the number on the x is going to be the top. So we can rewrite that as y to the 4/3 power. Cool? Now we can apply our power rule. So that would be y, and it's going to be 4 over 3x to the what power? You got it. It's positive this time, huh? Because the top is bigger. So what's 4 minus 3? A positive 1. So you actually end up with a positive 1/3 this time. All right. So let me throw a couple of these at you guys. I'll throw 3 at you. We'll see how you do. How about 2 over x squared? We'll call that A. For B, we'll say, how about y equals the 5th root of x to the 4th. And then for C, we'll say, how about 1 over 2 square root of x. Now, just so you guys know, when there's a square root of x, we don't write it, but what number is here? A 2. It's a square root. And what number is here? A 1. So as a power, that would be what? 1/2. Right. So go ahead.